Okay, so let's fix that issue. So we were thinking of the issue of having this stepping coming from our current solution for having particles sticking more towards the robot, but it's giving us this artifact, so we need to find another solution, and let's take care of that. So going to the pop network, the first thing I'm gonna make change is here on the source, we're actually using 100% of the velocity vectors that's coming in from our particles. And we can probably slow this down quite a bit. 0.2 will definitely not push them out immediately as much. And that's something that's gonna help right away. The other thing is on the subsolver, instead of just updating the position of the particles kind of suddenly and kind of giving us that, it's giving us that issue. So instead of doing that, we're not going to be using the ray. We'll instead update the force vector. All particles have a force vector, and that's kind of coming from all the forces that they're subject to. And that force vector will be used to update the velocity, which in turn will be used to update the position of the particle. And that'll be much more organic and much more fluid, and it shouldn't give us any step. So I'll call this attract. And what we'll do is we'll do something that we've done before, which is find out what's the nearest point on the surface. So let's say equal to near point on input 1 based on current position, and let's establish the same limit we had before, so we won't look for any points that are further away than 0.1 meters. So now we have our point. Let's get that point position. It's going to be equal to point from 1 position, and it's going to be ref pt. So we have the position. Now we need to figure out the direction towards that position. So let's call there. It's going to be equal to normalize. So let's normalize having the ref pos minus our current position. So we have the direction. Okay. And next, what we're going to be doing is multiplying the direction by something to create the final force vector, which is going to be vector attract, and this is going to be equal to the direction that we find out that we just calculated times a multiplier. And for now, I'm not even going to create a channel float. Let's start with something drastic like 10. And finally, we'll update the force vector plus equals. So we don't want to redefine the force vector. We just want to update it with this influence of the attraction force towards the surface of the object. So plus equals the attract. Okay, this is what we want to input. I missed something here. Near 0.1. Oops. Crazy David. And that's it. So let's go up. I'm going to reduce the density for this particular test. So let's go here and let's go back to 0.02. 0.02, and let's cache this one out and see what it looks like. Or rather than caching, let's go straight for the effect inside, and let's just scrub all the way to this frame, let it go through. Let me escape, so we don't actually need to have a lot of substeps. So we're currently calculating with 2 substeps. Let's keep it simpler so it's faster, and let's go here. Okay, looking at this, it's definitely taking effect. You can definitely notice that they're being pulled towards the surface quite a lot. Even though they're still being advected, they're kind of sticking to the surface like crazy, probably too much. So let's bring that value down, and I think we'll be in a good position. So I think 10 is too much, so let's try with 2. One more test. Here we are, so this seems much more reasonable. So they're definitely being pulled towards the surface. We don't see any stepping so far. They're still kind of being able to break through though. Okay, we can see there some of them will break through. So I think this is a really good option. Okay, let's give it a try with an actual simulation. So going up, increasing the resolution. Let's go 0.2. Last time I felt we could have more. And after that, I'm also going to go to the popnet. I'm not going to use substeps because I don't think we'll need them in this case. So let's save, and let's save to disk. So here we are with the final simulation, at least semi-final. And I think it's looking really cool. We don't have any stepping. They are staying really close to the surface at this point. Eventually they kind of release from the surface and it's kind of going away. Let's bring the other one as well, the blast, and I'll do a couple of flip books so we can have a look at everything coming along together. So we'll keep these. Let's have a look. Hit play. And we have all our elements in play. The particles envelop the character at certain point. We have those bursts. Pretty interesting effect at this point. And we still have a few more elements to add to the final result. So we'll keep going and I'll see you on the next lesson.